So I come across a question in my lab statistics that looked a little different than what we've been working with. Question 17, Chebychev's theorem on standard deviation. This question, I'm just going to pull right out of my lab. So at least 99.72% of the data in any set lie within how many standard deviations of the mean. Explain how you arrived at your answer. And the first question said, explain how the number of standard deviations could be found for any data set. Notice how it says any data set. The empirical rule only works for a bell-shaped curve data set. So that Chebychev's rule kind of came into play at this point. So remember Chebychev's rule, the K stood for the number of standard deviations. So we had K had to be greater than 1. And so what we chose first is like 2. So if we had like 1 minus 1 over 2 squared, that'd be like 1 minus 1/4, which would be like 3/4. So 2 standard deviations would be like 75% of the data, since that's 0.75, because you can change it to decimal. So Chebychev kind of creates this ratio or fractional form. So we call that, 75% of the data would be 2 standard deviations, where I think in the empirical rule, 2 standard deviations was actually like 95% of the data. So this is a little bit different. If I was 3 standard deviations, that would be like 1 minus 1/3 squared. That's going to be like 1 minus 1/9, which turns into like, as a decimal, that'd be like 8/9. As a fraction, would be 8/9. And as a decimal, that'd be like, if I rounded, it'd be like 0.889, or like 88.9% of the data would be like 3 standard deviations, 88.9%. So that's kind of where we are. We're looking for this K. But what they gave us, though, is they gave us this percent, this 99, what was it? 99.72%. So in our formula, we don't know what K is. But what we do know is that the percentage was this 99.72 or 0.9972. So I changed that to a decimal. So I actually can set up this equation to solve this problem. But that requires some college algebra. And this is kind of one of the harder types of problems we did in college algebra. So to solve for K, first thing, it's the variables in the denominator. So we want to get rid of the fraction by multiplying both sides by this K squared. That's the way I would do it. There's all kinds of ways you can do this. So when I bring the K squared through the parentheses, that's going to give me K squared. Here, the K squares would divide out, and that would just be a -1. On the right-hand side, we'd have this 0.9972 K squared. So this 0.9972 becomes the coefficient. Remember, the coefficient of this K squared over here is 1. Now, to solve an equation like this, we have to get the K squared on the same side of the equation. So I'm going to zero this out over here by subtracting 0.9972 K squared. But I also got to subtract it over here. So subtracting 0.9972 K squared. Okay, make that a little bit neater. That's just a little too messy. Go away. All right, so that's going to be that. So remember, since you have like terms, I can subtract the coefficients. So my calculator, I'm going to go 1 minus 0.9972. And that's going to give me this 0.0028. So 0.0028 K squared minus 1 is now going to equal this 0. Now, to solve for K squared, we still got to get the K squared by itself. So I'm going to add 1 to both sides. So it's going to be 0.0028 K squared is equal to 1 if I add 1 to both sides. Now, to get rid of the coefficient, we have to make that coefficient of 1. So we got to divide both sides by the coefficient, 0.0028. And I got to divide this side by 0.0028. So I got to do some more math on the calculator. 1 divided by 0.0028. And that gives me then about 357 if I round that. So K squared is going to be approximately 357. Now, to solve for K, I would actually have to take the square root of the 356. So K would actually have to equal the square root of 356. So that x squared button is above the x squared button, so I have to use that second button. So second, hit the x squared button, gives me the square root, put the 356 in, and that gives me about 18.8. So K would be approximately 19. So that would be like 19 standard deviations from the mean. That would be the estimation of that. So that's how we would have to go about solving that problem, is actually use a little bit of algebra and manipulate that. I didn't see any shortcuts. So if you come across some shortcuts on that, please let me know.